Springs. We encounter them everywhere. They can be found in pogo sticks, trampolines, and the pinnacle of human bouncing technology, moon shoes. In addition to helping us win our arms race against the kangaroos, springs have a number of practical uses. Just a few examples of things that have springs are cars, toasters, and Carrie's laundry chute. Perhaps some among you have stopped to wonder, how exactly do these marvels of technology work? It's one of the greatest mysteries of our time. Fortunately, there is an explanation. So let's spring into this interesting area of physics and get hooked on Hooke's Law.
Hooke's Law is a principle that explains how springs work. The basic foundation of Hooke's Law is that the force F used to contract a spring a certain distance x is proportional to the distance. This is represented by the equation F equals kx. K is a constant that represents the stiffness of the spring.
Isn't Hooke's Law amazing? We're going to test it out, but first we'll need a spring from this heart light.
Looks like this heart was broken. If we knew the force we applied to this spring, and if we knew the distance we stretched it, we could calculate its stiffness K by dividing the force by the distance. Unfortunately, we do not know those things. Fortunately, we have this Newton measurer, which by definition will tell us the force that we apply to the spring here. We can now measure the distance we stretch the spring and can solve for the stiffness K. In this case, the force being applied is 8 newtons. 7 newtons. 7.5 newtons.
The formula for Hooke's Law is F equals kx. However, the spring constant K is used for spring compression. We stretched a spring, so we will use negative K. Since this is the variable we are solving for, we will rewrite the equation as negative K equals F divided by x. We measured a force of 8 newtons. The application of this force caused the spring to stretch 0.054 meters. Solving this equation for negative K gives us the spring constant,
148.148 Newton meters, since the spring constant is neither positive nor negative.